Graad 8, dit is nog steeds Pythagoras wat ons nou gaan kyk, die stelling van Pythagoras, en elke keer as ek begin, gaan ek vir jou vra, sê vir my die stelling van Pythagoras, we'll get to the English just now. So die stelling van Pythagoras sê, in 'n reghoekige driehoek, sal die vierkant op die skuinsy gelyk wees aan die som van die vierkante op die ander twee sye. Sê dit saam met juffrou. In 'n reghoekige driehoek sal die vierkant op die skuinsy gelyk is aan die som van die vierkante op die ander twee sye. In a right-angled triangle, the theorem of Pythagoras says, in a right-angled triangle, the square on the hypotenuse side is equal to the sum of the squares on the other two sides. Say it again with me. In a right-angled triangle, it has to be right-angled, the square on the hypotenuse side is equal to the sum of the squares on the other two sides. Met ander woorde, die eerste ding is, dit moet 'n reghoekige driehoek wees. How do I make sure it's a right angle triangle? I say, okay, I see that y is 90 degrees given, gegee. So that means I've got the go ahead, I've got the ticket, the pass to go into Pythagoras. As ek nie hierdie ingangskaartjie het nie, kan ek nie na Pythagoras toe gaan nie. Hy is reghoekig, so daarom kan ek Pythagoras toe gaan. So, waar sit die skynsy? Where is the hypotenuse side? It is x, z. Well, how do I know that that is the hypotenuse side? Waar sit die skynsy? Teenoor die 90 grade hoek. So, die skynsy kwadraat, die vierkant van die skynsy, is gelyk aan die som van die vierkante van die ander twee sye xy en y. Z. Let me say that again in English. If you look at the hypotenuse side, then hypotenuse side xz, the square on the hypotenuse side is equal to the sum of the squares of the other two sides, x, y, and yz. Dit maak ons nou nie saak wat een van die twee jy eerste gesit het, doesn't matter. Very important, your reason, Pythagoras. It's worth a mark that you say, I know this fact, because Pythagoras said so, and we saw it by drawing those sketches. Okay, so nou vervang ek in. Substitution, x, z square is substitute. Jou substitutie reëls wat jy geleer het, sit die hakie daar en dan sit ek die 8 en die 10 daarin. It doesn't really matter if you put x, y as 10 and y, z as 8. We know what is what on the sketch, but it has to be those two added together. En dan vat jy jou sakrekenaar. Now, step by step, this would mean 64 plus 100, which gives me 164, which when I square root that, oopsie, I did this, I didn't want to do this, okay, but now I have, so it's going to give you an answer with a square root in it. So when you square root that, dan nou, dis nou die antwoord van die kwadraat, dan wil ek nou daai antwoord gaan kry deur te vierkant. Wortel is still in an equation. Sien jy, dis nog steeds 'n vergelyking. So wat ek links doen ek reg en ek wil die kwadraat weg hê. My purpose here to get xz alone is to square root it because I want to get the square away. So that means that xz will be equal to, and now you take your calculator and the answer is not a complete square. Hierdie is nie 'n vierkants getal nie. This is not a complete square, your square numbers. If you say the square root of 164, it gives you 12,806, which is 12,81. Want moet dit nou alles vierkante wees? Nou met 'n teken gaan bitterlik moeilik wees. To sketch it's going to be impossible to do. But there can be an answer with a comma, a decimal number, not a whole number. So jou antwoorde kan dit wel wees. So die antwoord van hierdie ding is, I go back to my sketch and I know that this is 12,81, which has to be the longest side because the sum of the squares on the other two, 8 and 10 is not 12, no. 8 square and 10 square will be equal to that one squared and that one squared, which was 164. Met ander woorde, jy kan nooit na die tyd gaan kyk en sê, "Juffrou, maar dis die 18 nie." It's not 18. It's not add the two sides together. Dit tel nie die sye bymekaar nie, dis die vierkante op die twee sye, die kwadrate van die twee sye. It's not just add the sides, it's add the square plus the square. And it will not give you the side, it will give you the side square. Goed, dit was jou huiswerksom. Kom ons kyk vandag na 'n nuwe voorbeeld. Want nou hierdie keer gaan ek vir jou sê, vind vir my nou vir daai sytjie. Is that the hypotenuse side? Is dit die skynsy? Nee, dit is nie. Waar is die skynsy? Where is the hypotenuse side? That is the hypotenuse side. Daar's jou skynsy. So I have given you the answer of the hypotenuse side, and I'm asking for one of the rest. Now the important thing here is to know you've got an equation. So you can in an equation get any one of the answers because you know how to work with an equation. But first things first, I'm going to use Pythagoras because it was given that it's a 90-degree triangle. Jy kan nie aan Pythagoras raak sonder 'n 90-grade hoek nie, sê hom weer. Die vierkant op die skynsy, so the square on the hypotenuse side, MP squared, will be equal to the sum of the other two. Now, I don't know what MN is, but the square of MN plus the square of NP will give me MP squared. It stays the same. Die vierkant op die skynsy is gelyk aan die som van die vierkante van die ander twee sye. Now, this is the one I'm looking for. Not that one, but it's okay. Don't forget to write your reason. Jou rede moet altyd daar wees vir die stelling van Pythagoras. Kan jy sien? It's always going to be 90 given. Always going to be Pythagoras and you write this correctly. Nou gaan jy invervang. Maar nou het ek vir MP. En ek het nie vir MN nie, maar ek het vir NP. I have NP squared and the 17 squared. But this is still an equation. Jy kan ons nou die som gaan oplos deur vir daai ding alleen te gaan kry. That's option number 1. Just to let you see that you can always work with an equation and take it across like you want to. So om vir MN alleen te kry, to get MN square alone, you can now first get the answers or first take it across and say 17 squared minus 15 squared. Remember about words. Alternative, 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 because there's a lot of ways that you can do this. As ek nou gaan sê 17 kwadraat, and it's actually one that you can know, it's 289. And 15 kwadraat wat 225 is, I can first do that, then take it across, because remember now 289 is going to be minus with 225, because I need to get MN. Maak dit saak dat die MN aan die regterkant sit en nie aan die linkerkant nie. The one I'm looking for doesn't have to sit on the left-hand side. It can stay on the right-hand side. And when I subtract that, I get 64. En my antwoord is nog steeds MN kwadraat. Ek soek nie vir MN kwadraat nie. I'm not looking for the side square. I'm looking for the side. How do I get rid of that square? The opposite of square is square root. So the opposite of square is square root. So you square root both sides. And that means my answer then will be 8 for MN. So op my skets gaan skryf ek daar moet dan 8 wees. Is hierdie twee bymekaar getel gelyk aan 17? Nee. Is 8 and 15 equal to 17? No, it must be 8 squared plus 15 squared. That'll give me 17 squared. Because Pythagoras is all about squares. The square on the hypotenuse is equal to the sum of the squares on the other two sides. Nou, dit was opsie nommer 1 gewees, ek gaan vir jou 2 van hulle wys. That was option number 1. If I just substitute it as it is. Now, I can erase that. You've got to write that down now. And now I'm going to show you that instead of writing it that way, you can now also tell yourself, but okay, if the sum of the squares gives me the hypotenuse, and I'm just looking for this one, hoekom kan ek nie eerder maar net vir hom sê, maar goed, then it's always going to be the hypotenuse side, die skynsy, always going to be the skynsy or the hypotenuse side, minus the other side. Now that you're not going to write in a test, hierdie is sommer net vir jou vir 'n aantekeningkie. So then if I want one of the other two sides, it's always going to be hypotenuse, which is NP squared, minus the other one that I have, which is NP squared. That was another way of writing it. And some people like to say, if you're looking for the hypotenuse side, it's the sum of the other two. If you're looking for any other side, not the hypotenuse, it'll always be the hypotenuse minus the second one that was given. Jy moet altyd 2 gegee hê. You always have to have 2 sides given, then you can get the third one. Nou sê party mense, hulle wil eerder altyd begin en sê, die een wat jy soek, the one that you're looking for will be equal to. Then it has to be the square on the hypotenuse minus the other one. Because it comes from the sum of the squares on the other 2 sides, but you're manipulating. Dit kom van daai reël af, maar nou gaan ek manipuleer. Baie mense voel, dis vir hulle te deë mekaar. Many people feel that this is too deë mekaar for them. It's way, I can't get the hang of it. I'm rather going to stick to my option number 1. I have to show you this, because some people will show you this and then you don't know what's going on. You can manipulate an equation. Remember what I said about an equation? You can add a million on the left as long as you add a million on the right. We don't know what your purpose is, but it's not wrong. You're not getting anywhere, maar dit is nie verkeerd om byvoorbeeld aan elke kant 7000 af te trek nie. Nou goed, as ek nou vervang vir NP kwadraat, dan gee dit vir my 17 se kwadraat, and NP square gives me 15 square. Please be careful, it's not minus squared, it's minus in between. So 225, and this is still going to be 189, and if you subtract, it's still going to be 64. So mn squared, again, wat ons nou nog gekry het, was hy ons ook 64 and our square root to get both sides alone, and the answer is still going to be 8. Either way you do it, it's going to stay the same principle. So you can go and say, I want to always write it in this form. If I ask you for something other than the hypotenuse side, it's going to be a subtraction sum. Or you can stick to the formula, substitute in, and then do your equation by putting it to the left and putting it to the right. Okay, let's look at another example. So you see a triangle. You see it's right angled. You see you've got 2 sides, so you must work out the third side. So the tool that's applicable is not parallel lines, not sum of the angles of a triangle, not vertically opposite angles. The right tool is, if I want a side in a right angled triangle where I have 2 sides, Pythagoras. Die hele lang storie in Afrikaans. As ek vir jou vra om vir my die lengte van 'n sy uit te werk en ek gee vir jou 'n reghoekige driehoek waarvan 2 sye gegee is, dan is die regte tool om uit te haal Pythagoras wat jy moet uithaal. So in jou Pythagoras sommetjie gaan jy moet gaan uitwerk wat is PR. So om vir PR te kry en ek gaan Pythagoras uitwerk, moet dit onmiddellik eers wees omdat P 90 grade gekeer is. Gaan ek sê die sye moet ek gaan van mekaar aftrek of by mekaar gaan tel. So hierdie sy gaan dan 'n aftreksom wees. If you want to do what I showed you the second option in the previous one, you can. You can start off and say PR square is RT, which is the hypotenuse side, minus PT wat die ander sy gaan wees. If that is unsure for you, because alternative, you can always start with the normal one that says hypotenuse side. Now what's die skyn side? Which is the hypotenuse side? RT squared will be equal to the sum of the other 2 sides. It doesn't matter, PR squared plus PT squared. Of dan nou jou ander opsie sou gewees het. If I want to say PR squared, dan is dit gelyk aan die skynsy wat RT is, trek of PT kwadraat. So I'm not going to do 2 every time on the board. We have to make a choice. Most kids like to use one specific sum. They don't like to sometimes do a minus, sometimes a plus, but that's how many people understand and know it. If it's the hypotenuse you're looking for, it's a plus sum. If it's not the hypotenuse, it's a minus sum, and this is always the hypotenuse. Dis sal altyd die skynsy wees as dit die aftreksom is. So om een van hierdie sye te gaan kry, is 'n aftreksom. Die skynsy trek af die ander sy wat gegee is. If I have to get a side that's not hypotenuse, it'll always be that side is the hypotenuse minus the other one. So you can do any which one of them. Our answers have to be exactly the same. So we have to make a decision now. Are we going to sometimes do plus, sometimes do minus? Most kids go on and they say, I want to do this one. So I want to go and say, for PR square, the one that I'm looking for, I'm going to, don't forget, whichever one you used, you have to say Pythagoras. Moet jy nou twee somme gaan doen? You're not going to do two sums. I'm showing you so that you can see it works out the same. So as ek sê om hierdie uit te werk, gaan dit die skuins, RTW is wat skuinsy is, kwadraat. Now I add something new here. 5 meters. So you can put the meters there, but you don't have to in mathematics. In science, they do want you to add all of your units as well. Hulle wil al die eenhede altyd by hê in fisiese wetenskappe. Maar in wiskunde kan jy net as 5 skryf en dan daai ene gaan dan wees minus met 3 se kwadraat. Remember your brackets. So jy hoef nie meters by te skryf, but you can put the meters in there, but kids usually get confused. Because 5 meters squared is 25 square meters. And then you're going to get confused and think you've got to square it again. Dan raak jy dit mekaar en dink ek moet hom weer gaan kwadreer. So los hom eerder weg. Minus and that will be 9. So that answer gives me 16. So if I've got PR square, dan moet ek mos nou weer om die kwadraat weg te kry. Remember, I'm working with an equation and I'm trying to get PR. How will I get just PR? I've got to get the square away by square rooting, and the answer then is PR is 4. But now we're going to add 4 meters. Because the sum was in meters. So you don't have to put the meters in from the start, only at the end. Nou goed, kom ons kyk hoe lyk in die ander formaat. Please don't do 2 sums for each and every one of them. I want to convince you that if you're looking for the hypotenuse side, it's going to be a plus sum. If you're going to work with not the hypotenuse side, it'll be a minus sum, but it'll always be hypotenuse minus whatever the other one was. So as dit die skuinsy is wat jy gaan soek, gaan dit altyd die plus som wees, want die vierkant op die skuinsy is die som. The square on the hypotenuse side is equal to the sum of the other 2 sides. But if you're not working with the hypotenuse side, as jy nie met die skuinsy gewerk het nie, gaan jy dan altyd sê, maar dis die skuins ene, trek of die ander, and it has to be this hypotenuse first because that's the largest one. Dit moet eers die skuinsy wees, want hy is die groter ene. So as ek dit gaan dan doen met die oorspronklike een wat sê skuinsy wat 5 is, PR, that is the one I'm looking for, and PT that was 3, and again I don't use the ends with it, then I'm going to say 25 equals PR squared plus the 9, because 3 times 3 is not 6. And then I'm going to do what I would normally do in an equation. I'm going to take the 9 across, so 25 minus 9 is PR squared, which still gives me PR squared is 16. Maak nie saak wat jy doen nie, jy kom by dieselfde antwoorde uit. But now I'm not looking for PR square, I'm looking for PR, so I've got a square root. And voila, PR is still equal to 4. Different technique, same theorem. But the theorem says if I'm looking for the hypotenuse, it's the sum of the other 2. If I'm not looking for the hypotenuse, it's got to be a minus sum. And it's got to be the hypotenuse first and then the other one. So we're going to stick to this now as a class, but you are welcome to use another technique. Verstaan almal, daar's altyd 'n alternatief en as jy nie weet hoe hy werk nie, kan jy op 'n ordentlike keuse maak nie. I'm going to do it this way from now on. So if I see that I'm not, where's the hypotenuse? T is the angle that's 90, so this is hypotenuse. So the one I'm looking for is not hypotenuse. So this must be a minus sum. Hierdie moet 'n minus som wees, want ek soek nie die skuinsy nie. Hierdie ene wat soek ek, am I looking for the hypotenuse side? AC? Ja, hy is die skuinsy. So this is going to be a plus sum. Sê gou eers weer, die vierkant op die skuinsy is gelyk aan die som van die vierkant op die ander 2 sye. The square on the hypotenuse is equal to the sum of the squares of the other 2. But if I'm not looking for the hypotenuse, then this one square will be hypotenuse squared minus the shorter one. Has to be hypotenuse first, want hy is die langer enetjie. Goed, so jy gaan 2 sommetjies doen vir huiswerk. Dankie.